Hello, I am Taylor Brown, and this is my midterm. This is exercise 1. So I have all of my resistors connected up here on my breadboard, and I'm supplying it with a volt of power from this power supply. And I'm just gonna be measuring the voltage across each resistor. So for the voltage across R1, I've measured it to be 680 millivolts, and it was calculated to be 666 millivolts. Now for the voltage across R3, I measured it to be negative 85 millivolts, and I calculated it to be negative 86 millivolts. For the voltage across R4, I measured it to be 344 millivolts, and I calculated it to be 334 millivolts. And finally, for the voltage across R5, I measured it to be 424 millivolts, and I calculated it to be 420 millivolts. All right, now I will be measuring the current through all of our resistors. So for measuring the current across them, you have to break the circuit. So I've just connected this end of the multimeter to the resistor and this end to ground. And I found the current through R1 to be 2.15 milliamps, and I calculated it to be 1.417 milliamps. All right, now I'm gonna be measuring the current across all of the resistors. So I've broken the circuit here. So I'm measuring the current across R1, which is right here. So I have the power clip connected to the resistor and the ground one connected to the line that the resistor would be in. So I have the wire set up right here, which is like the row that this would otherwise be in. And I measured the current to be 1.44 milliamps, and I calculated it to be 1.417 milliamps. So I'll just continue this process to measure the current of all the different resistors. All right, now I've measured all of my currents across all of my resistors. And for my last one, R5, I got 0.77 milliamps. And these right here were all of the measured versus calculated currents for the resistors. All right, now, since I forgot to earlier, I'll be measuring the resistance of all of my resistors. So for R1, for example, it's giving me 469.7 ohms, when in my calculations I used 470. So I'll just be measuring the resistance of all of these with the multimeter. All right, this is my R5. It gave me 561.8 ohms, and I just finished all the rest of my resistors. So here was their measurement versus their calculated value. Okay, now I'm on exercise 2 of the midterm, and here I have a RC circuit, and then I'm using my function generator to generate a square wave at 1 kilohertz, and then I've adjusted the amplitude on here for the output to be about 1 volt, and the yellow square wave here is my input, and the channel 3, the purple line, is the voltage across my capacitor. So we can see it charging and discharging. Here I'm measuring for tau. I measured my max voltage to be 1.87. So here is where the voltage is at 63% of the max, and the time where that happens is 96 microseconds, which is pretty close to my calculated 100 microseconds. All right, now I'm on exercise 3 of the midterm, and here I have my RL circuit. So I have my RL circuit constructed here, and I've connected my oscilloscope. I've connected channel 1 across the whole thing to measure the source, and then I have channel 3 connected across the inductor right now. So here on my oscilloscope, the yellow line is my source, and the pink line is the voltage across my inductor. So now I'm just going to measure the amplitude and the phase shift between the two lines. Here I'm looking at the phase shift between my voltage source and the voltage across my inductor. So I found that the peak-to-peak difference is 236 microseconds. So using the formula, I also found the period to be 936 microseconds. So I just did 236 divided by 936 times 360, and I got 90.77, which was pretty close to my 89.64. Alright, I am still in exercise 3, but now I'm going to be looking at the phase shift between the source and the resistor. So I've just put these two wires here to make connections easier, but this channel right here, channel 3, is measuring across the resistor. So here on my oscilloscope, I have the yellow line being the source and the pink line or purple line being the resistor. And if I change the scaling here, they're nearly identical. They are a tiny bit different, which is what I was expecting. So now I'll just calculate the phase shift and then find the amplitude to find the voltage across the resistor. Alright, now I'm measuring the phase shift between my inductor and my resistor. This is as close as I could get the two vertical cursors together without them overlapping. So it gave me 4 milliseconds. And once I calculated, it came out to 1.538 degrees. That is a lot more than what I calculated though, but that's due to me not being able to move the cursors closer than 4 microseconds without it being 0. Okay, now for the last part of exercise 3, I'm just measuring for the current through my circuit. And since this is a linear, just a simple series circuit, I can measure the current across one component, and then that's the current for both components. So I'm just going to measure the current through the resistor here. I've broken it and then connected the other probe to ground, and I'm getting a reading of 2.53 milliamps, and I calculated it to be 2 milliamps.